that we are looking at is helping us to organize our rules that we learned back in Algebra 1 and Algebra B. In the top row, you see that it says adding and subtracting monomials. Adding and subtracting monomials. The rule for that is that you are going to combine like terms. If you're adding and subtracting, we don't do anything to the variable or the exponent, do we? We just add the coefficients. Okay. So I want you to make a little note. I'm going to add the words in here. Add or subtract, depending on what you're doing. Coefficients. Add or subtract coefficients. Please write this with me, guys. In your notes, you should be copying down what I copy down. I wrote add or subtract the coefficients. When you are combining like terms, add or subtract the coefficients. We do not change the variable or the exponent. So if you look at the examples here, we have 9x squared y minus 10x squared y. We have like terms, agreed?
Yes.
Same variable with the same exponents. So just add or subtract your coefficients. Well, what is 9 minus 10? Negative 1x squared y. We don't do anything to our variables. And of course, this could also be written as negative x squared y. On example 2, it says subtract 6w from 8w.
2w.
So we're taking 8w and we're subtracting from it 6w, correct? We're taking 6w away from 8w. So 8w minus 6w is 2w. The next rule is talking about our product rule. What does the word product mean? Okay, I'm going to put a multiplication symbol above product just to indicate that we are multiplying. Do you remember what we do to our exponents?
Add them.
We add them. When we multiply our bases, we add the exponents. So I want you to write in your rule. Our rule is x to the power of a plus b. Michael, you got to wake up, please. A plus b. Now we obviously don't know what a and b are, so we can't actually add those two together. But if we knew the numbers, then we could. So look at example 1. We have h squared times h to the 6th. So really this is h to the 2 plus 6. Well, 2 plus 6 is 8. H to the 8th power. You guys remembering this stuff from Algebra 1 and Algebra B?
Do we have to write 2 plus 6?
No, you don't need to write that. So h to the 8th power. Thank you, Hallie. Sit down, huh? Now, example 2, there's multiple variables, there's coefficients that we've got to take care of. You can remember, you can always rearrange this. We are multiplying, and multiplication is what we call commutative. It means you can put it in any order you want. So I can make this negative 2 times 7 times a squared times a cubed times b. Well, let's clean this up. What is negative 2 times 7? We have negative 14. A to the what power? What do we do with our exponents? Add them. 2 plus 3 is 5. B to the second power. If there's not an exponent, what is understood to be up there? What is that exponent? It is a 1. 1 plus 1 is 2. Next rule is called the power rule. What do we do with our exponents here? Multiply. This is the case where we multiply. So let's write our rule in. It's going to be x to the a times b power. Of course, we don't know what a and b are, so we can't actually find the product. It's just going to be a times b. So the power, and we're raising it to another power. Let me back up for a second. Do you know what I mean when I say power? If I have x to the 8th power, 8 is considered my exponent or my power, right?
Yes.
Okay. We're raising it to some power. So in the example number 1, we have x squared cubed. We want to simplify this. What do I do with those exponents in this case? Multiply. 2 times 3 is? 6. X to the 6th power. And again, somebody asked us a second ago, do we need to write 2 times 3? Or do we need to write 2 plus 6? No, if you can do that in your head, you don't need to. I'm writing it out just so you can have a clear explanation. Now in example 2, we've got several things going on. The first thing I would clean up is this parenthesis here. We have negative 2m to the 5th all raised to the 2nd power. So do I just take 5 times 2?
No. Negative.
What else do I need to do?
Negative 2 squared.
I need to do negative 2 squared. It is squaring everything inside. So think about what that really means. Isn't that negative 2m to the 5th times negative 2m to the 5th?
Yep.
Okay. Times m cubed. That's what it really means. So really, we can rearrange this. We can make this negative 2 times negative 2, m to the 5th times m to the 5th times m cubed. Negative 2 times negative 2 is a positive 4. M to the 5th times m to the 5th is really m to the 10th. M to the 10th times m to the 3rd is m to the 13th. I'm sorry.
Are we multiplying 5 times?
No, I would have taken 5 times 2. Think about how I have this written. I wrote it out in an expanded form. I could have taken 5 times 2, which would give me m to the 10th. And m to the 10th times m cubed would be m to the 13th. But because we have it written out as we're multiplying our bases. Guys, Will, I would really appreciate it if you would stop talking. Okay? Thank you. Would be a huge distraction back there. So we have positive 4m to the 13th power. The last example, or not last, but the next examples are using the quotient rule. What does quotient mean? Division. Quotient means division. So when we're dividing, what do we do with our exponents? No. What do we do? Michael, you gotta wake up. Gotta wake up. Write these notes down. What do we do with those exponents?
Subtract.
Subtract. Okay, we are gonna subtract. So we're gonna do top exponent A minus B. Can I give you an easy way to remember to subtract? Because I know a lot of people want to divide, or they want to, just to get different things. What does this division line right there look like? Does it look like a subtraction sign?
Yes.
Okay, so when you see that division line, it looks like a big subtraction sign. Big subtraction sign. So we are subtracting our exponents. And we always do top minus bottom. A minus B. But those are only the exponents that we are subtracting. Look at your example here. Number 1. We have 27x to the 5th divided by 42x. Now, I'm not going to take 27 minus 42, correct? Those are not exponents. Those are coefficients. I want you to think instead of what goes into 27 and what goes into 42. Okay. 3 goes into 27 how many times? 9. And 3 goes into 42 how many times?
14.
14. So we have the fraction 9/14. Michael, you have to wake up. The next time I'm going to make you stand up. What do we do to our exponents on the x's? Subtract. We have a division, so we're subtracting. It's going to be x to the 5 minus 1 power. Well, what is 5 minus 1?
4.
4. So we have 9 over 14 x to the 4th power. And that would be in the numerator. Example 2 here. Let's look at that one. Before we work on our division, we have to clean up the numerator. We have y squared squared. We have a power raised to a power, what do we do with those exponents? Multiply them. So y to the fourth power divided by y to the fourth power, it's 1. Okay, why? Well, what do we do when we're dividing? What do we do with our exponents? Okay, so really we have 4 minus 4. Well, 4 minus 4 is, what's anything to the 0 power? Is 1. Anything to the 0 power is 1. We have one more rule here. This is the negative exponent rule. Yeah, we did. We changed floors. Back in algebra 1, we talked about that, changing floors. Here's nothing else. Change, another silly thing I've got to remember. Change the line, change the sign of the exponent. Okay, think about what I just said. Change the line, change the sign. So what do we know that exponent makes us do? Change floors, right? So if we change the line, we're going to change the sign. So if we move to the other side of the line, this division line here, we're going to change our sign. So it's going to be x to the positive a power. Change your sign to make it positive. So 1 over x to the a. And again, that only applies to exponents. Okay? Only applies to exponents. It does not do anything to your coefficients. Let's look at our examples here. Number 1, we have negative 5x to the negative 2 power. Does this negative 5 change floors?
No.
No, it's not an exponent. The negative 2, x to the negative 2 is going to change floors, right? So we're going to change the line. When we change the line, what happens? Change the sign. Let's make it a positive. The negative 5 is going to stay in our numerator. Michael, why don't you stand up for a little bit? You want to just hold your book in the back of the room?
Okay.
I know you've been busy. Just stay awake, okay? Number 2. What would you do first? I wouldn't subtract first. 4 eighths. What goes into 4 and 8? 4 goes into 4 once and into 8 2 times. We have 1 over 2. Now for the k's, we're dividing. So what does that division sign look like? Subtraction. So we're going to subtract those exponents. 2 minus 5.
Negative 3.
So k to the negative 3 power. Never leave a negative exponent in your final answer. We have a negative exponent, so what does that mean? Change floors. When you change, cross the line, change the sign. Cross the line, change the sign. So the 1 is still going to be the numerator. We're going to have 2k cubed in the denominator. Now, we're going to get into some more challenging examples here. Example A, if I gave you that, would you be able to simplify this? Can you see it? Is it kind of small? It's kind of hard to see. Let me rewrite it. So we have a to the negative 3 times a squared b to the 4th times c to the negative 1. Thoughts? What are we going to do? What operation are we doing amongst all of these variables? Multiplication. Okay. Multiplication is commutative, right?
Yes.
I'm going to rewrite this without all these parentheses. I'm going to write it as a to the negative 3 times a squared times b to the 4th times c to the negative 1. Now, we just learned that if you're multiplying your bases, you're doing what to those exponents? Adding them. So let's start with the a's. Negative 3 plus 2. Negative 1. So we have a to the negative 1 power. B to the 4th, is there anything I can combine with that? 1. Anything I can combine with that? I'm still not finished. We never finish a problem with a negative exponent. I have two variables with a negative exponent. So they're both going to cross the line, and then we're going to change the sign. So we're going to cross the line with a to the negative 1 and c to the negative 1. So they're both going to go down to the denominator. What about b to the 4th? Does it go too? No, it's going to stay put. It's going to stay in the numerator. It does not have a negative exponent. So b to the 4th divided by, well, when a comes down, they'll cross the line, thus change the sign. It's going to be a positive 1. So a to the 1st, or just a. C to the negative 1, when you cross the line, change their sign there. So it's going to be c to the positive 1. So b to the 4th divided by a, c. About this one? I know it's tough to see. It's kind of small. So we have x to the 4th, y to the 5th, times xy to the negative 3 power. Copy these examples down, guys, because they're good examples that can help you with your assignment. Now, is there anything, we're still using order of operations, that doesn't ever go away. Is there anything inside the parentheses that we need to do? Looking here in this parenthesis. There's nothing I can do just with that parenthesis. Look at this parenthesis, or anything inside that parenthesis we can do there? No. Now, moving to exponents, there is an exponent that we can take care of, correct?
Yes.
We need to distribute that negative 3. It goes to both of those variables inside. So that's what I'm going to do first. Please do this with me. So we have x to the 4th, y to the 5th, times x to the negative 3, y to the negative 3. Now, could you simplify to distribute that exponent? We should be able to. Multiplication is commutative, means you can multiply in any order you want. So let's rearrange. M to the 4th times x to the 4th times x to the negative 3. My y's together, y to the 5th times y to the negative 3. When we're multiplying our bases, what happens to our exponents? Add them. 4 plus a negative 3 is 1. So we have x to the 1st power. Y to the 5 plus negative 3 is 2. So we have x to the 1st, y squared, or really just x, y squared. About this one, we have n squared divided by n to the 10th. N squared divided by n to the 10th. When we're dividing, what's our rule for our exponents? Subtraction. So I'm going to take 2 minus 10. 2 minus 10 is? Negative 8. 2 minus 10. 2 minus 10 is negative 8. Into the negative 8. Again, we cannot leave a negative exponent in our final answer. So if we have a negative exponent, we need to cross the line and change our sign. So we're going to take into the negative 8th and move it to the bottom side. Cross that line and change our sign. It's now a positive 8. What do we put in the numerator if there's nothing left? 1. A 1. 1 over into the 8th. Can't see it, let me rewrite it. 3a cubed divided by b to the 4th all squared. Again, use your order of operations. They're still there. Is there anything inside of our parenthesis that we can do to simplify? Inside the parenthesis. There's not. So go to your exponent. What are we going to do with that 2 on the outside? Distributed. It's going to go to every single variable or coefficient in that problem. So let's do that next. So we have 3 squared. We have a cubed squared. And we have b to the 4th squared. Yes.
We're gonna try that step out there.
You could do that one in your head. What is 3 squared? Is that 3 times 2 or 3 times 3? 3 times 3 is 9. 3 squared is 9. Here we have a cubed squared. We have a power, we're raising to a power. Power to a power, what do we do? Multiplying 3 times 2 is 6. 9, a to the 6th. Divided by b to the 8th. 4 times 2 is 8. Let's do this one here. 2x to the 4th y times 8x squared y divided by 32x cubed y to the 6th. Using order of operations, of course, we start with parentheses. Is there anything inside of our parentheses that we can do? There's not. Yes.
What's the y?
6. There's nothing inside that parentheses that we can do. So let's go to exponents. Is there any exponents that we need to distribute out? No. And really, when you're doing these, the only thing you're doing with an exponent is to distribute. Sometimes you're multiplying, but there's nothing. Is there multiplication that we can simplify? Yes, the numerator has lots of multiplication going on. We can simplify. We could rewrite this as 2 times 8 times x to the 4th times x squared times y. The denominator is going to stay as it is, 32x cubed y to the 6th. So if we clean up this multiplication, 2 times 8 is 16. X to the, that's a 2 there. X to the 4th times x squared is x to the 6th. We add those exponents. Y to the, y times y is y to the 2nd. Divided by 32x cubed y to the 6th. Did you get caught up? Continue to go on looking at your coefficients. 16, and that should be 32 and not 3 down there. I apologize. Let's change that 3 and make it a 32. So what number goes into 16 and 32? We're going to simplify that fraction. 16. 16 goes into 16 once, into 32 how many times? Twice. So we have 1 over 2, or 1/2. Let's go through each individual variable. We're dividing, so what do we do to those exponents when we divide? Subtract. So 6 minus 3 is 3, x to the 3rd. Always goes to the numerator. 2 minus 6 on your y's. -4, so y to the -4, again, goes to the numerator. Now, of course, we can't leave our variable with a negative exponent. So we're going to have to cross the line and change the sign with that y. Change floors, move it down. When you change it down, of course, that's become a positive exponent. So we have 1x cubed, or just x cubed, divided by 2, y to the 4th. I have one more example that I want to go through with you, and that will be it for today. So please make sure you do have this last example into your notes. Two a squared, e to the -3, divided by ab squared. raised to the negative 3 power. I would encourage you to start with your parentheses like I've been saying. Inside the parentheses, is there anything you can simplify? Yes, we'll start with our a's. A squared divided by a is really a to the what power? First power, 2 minus 1. So we have 2a to the first power. What about your b's? When we're dividing, what do we do with the exponents? Subtract. So we have negative 3 minus 2. Negative 5. You could, at this point, change floors with that b if you wanted to, but I'm going to wait because it's going to work out really nice, actually. Now, parentheses is taken care of. Exponent. What am I going to do to that negative 3? I'm going to distribute it. Everything is going to be taken to the negative 3 power. So we have 2 to the negative 3 power. We have a to the negative 3 power. And we have b to the negative 5 to the negative 3 power. Now please don't type 2 to the negative 3 in your calculator because you're going to get a decimal. Okay? That negative exponent tells us we're going to change floors. Okay? We're going to cross the line and change the sign. So I'm going to move this. I'm just going to go ahead and move it. I'm not going to do any calculating yet. I'm just going to move that down to the denominator. So we have 2 to the negative 3 in the denominator. Well, what is 2 to the negative 3? 2 to the third power. 8. Can I go ahead and replace it with 8? It's not going to be negative 8 because it's really going to be 2 to the third power. 2 times 2 times 2. It's not going to be negative 8. So change your sign. Now, a to the negative 3, that's also going to go down to the denominator, isn't it? So we have a to the positive 3 power. Now in the b's, we would take negative 5 times negative 3, which is really a positive 15. So it would be b to the positive 15. Will that go to the denominator? No. That's going to stay in the numerator, it's not negative. B to the positive 15. Guys, these are rules that you learned in Algebra 1. We are taking them a little bit further than you did in Algebra 1. We're applying all these rules all at once. We will spend a couple of days on this. But I do expect that you remember this from Algebra 1. If you have any questions or you need some help, you know you're welcome to come in before school, after school, or any advice, or come see me and put this together. But you've got to know these rules. That handout that you filled out, I hope will be a good resource for you to use as you're going through this. I do have some problems for you to try to do. I want you to get started on them. You do have some time in class to utilize. We verify this is the right assignment. Page 337, 1 through 4 all, 16 to 23 all, and then 42 through 50 evens. Please go ahead and get a textbook. If you need to borrow one, just trade me something. I'm going to put my shoe on.